Hi, I'm Melissa Hartwig, and I'm going to be doing an example of variation on parameters from Trench, section 9.4, number 22. I have the original equation written out here, as well as we are given the complementary solution and values for y prime, and y double primed all at 1. Now the first thing that we have to do is we have to get this equation into the standard form so that we can use variation on parameters. And we do that by dividing through by x cubed so that the y triple prime has a 1 in front of it. So that we will end up with y triple prime minus 2x to the minus 1 y double prime plus 3x to the minus 2 y prime minus 3x to the minus 3 y equals 4x to the minus 2. So the next thing that we're going to do is we're going to put together our first Wronskian. So we'll have w equals, we're going to have our y1 right here. This is y2, and this will be y3. And so here we'll have y1 prime, which is just 1, and y1 double prime, which is 0. For here, we'll use y2, which is x cubed. And so this would be 3x squared, and double primed would be 6x. And then for our y3, we have x ln of x, which will give us a first derivative of 1 plus ln x, and that is using the product rule. And then our double prime will just be 1 over x. All right, this takes a little bit of doing, but we will have, I'm just going to move this up so I have more room. Okay, x times 3x minus 6x minus 6x ln of x minus x cubed times 1 over x plus 6x squared ln of x, which we can simplify. We'll have 3x squared minus 6x squared minus 6x squared ln of x minus x squared plus 6x squared ln of x. Now these will cancel out, so we're just left with 3x squared minus 6x minus x, which will give us a minus 4x squared. So I'm just going to write that over here. W equals minus 4x squared. Okay, so now what we have to do is we have to find Wronskians for each of these. We're going to have to find 3 of them because we're on a triple prime. So our first one, we put the solutions first. We've got a 0, and then right here is what's going to go down here. So it'll be 4x to the minus 2. And then we'll use our x cubed term for our y2 and its derivative. So 3x squared, 6x, and then our x ln of x, which we know is 1 plus ln x, and 1 over x. Okay, and this becomes, we have a 0 here, so there's no first term, so we're going to start with a minus, and it's going to be the x cubed term times minus 4x to the minus 2 minus 4x to the minus 2 ln of x. And this is because we've got a 0 for this first term, so this has to become a negative here. And then the last term is plus x ln of x times minus 12. And this simplifies down. We'll have 4x plus 4x ln of x minus 12 ln of x, which gives us 4x minus 8x ln of x as our W1. And then we'll do this again, our W2, where we'll put our solutions in place of our y2 numbers. So we'll come back, we'll have our y1 and its derivatives. We'll have our solution set in our y2. And then our y3. I guess I could have left that there. And we'll just change this little 1 to a 2. And for this, we will get x times minus 4x to the minus 2 minus 4x to the minus 2 ln of x, for the same reason as last time, plus x ln of x times 4x to the minus 2. And this will simplify to minus 4x to the minus 1 minus 4x to the minus 1 ln of x plus 4x to the minus 1 ln of x. These will cancel out one another, which will just leave us with a minus 4 over x for our W2. And then for our W3, we'll leave our first column and put our second column back in. And our solution set goes in the third column. And this becomes x times 12 minus x cubed times 4x to the minus 2, which equals 12x minus 4x, which gives us 8x for our W3. All right, now we're going to take this information, and I'm going to go ahead and erase this. I will leave some of the original equation up here though. Okay, so now we're going to work our way towards the form that we're looking for, which is y sub p equals u1 y1 plus u2 y2 plus u3 y3. So we need to solve for our u's. So the way we do that is u1 prime is going to equal our w1, which is 4, well, I guess should be w1 over our w. Okay, and that is going to equal 4x minus 8x ln of x all over minus 4x squared, which will simplify to minus 1 over x plus 2 ln x over x, which can be rewritten, but I won't because they leave it in this form. So u2 prime will equal w2 over w. So we will have minus 4x to the minus 1 over minus 4x squared, which is going to leave us with 1 over x cubed for our u2, or u prime 2, excuse me. And u3 prime, which will equal w3 over w, will give us 8x over minus 4x squared, which gives us minus 2 over x. I'm going to go ahead and put these over here. We've got u1 prime equals 2 ln x over x minus 1 over x. u2 prime equals 1 over x cubed, and u3 prime, which equals minus 2 over x. All right. Now from here, we have to solve these for u by taking their integrals. So u1 is going to equal the integral of u1 prime dx, which is going to equal the integral of 2 ln x over x minus 1 over x dx, which is ln of x squared, which you can do with a u sub, but I feel like we should all know how to do that by now, minus ln absolute value of x. Although the absolute value signs do drop out, but I think it's kind of important to put them in here. This would be plus a c1. We won't use that later either because those are already accounted for in our complementary solution. So then u2 would equal the integral of u2 prime dx, which is going to equal the integral of 1 over x cubed dx, which equals negative 1 over 2x squared. And then our u3 prime will equal the integral, u3 will equal the integral of u3 prime dx, which is the integral of minus 2 over x dx, which is minus 2 ln of x. So now we have our u values. And we're going to put these and the values that we have for y1, y2, and y3 together to get our full y sub p. So y sub p is going to equal ln of x squared minus ln of x times x minus 1 over 2x squared times x cubed minus 2 ln of x times x ln of x. And this simplifies down to x times ln of x quantity squared minus x ln of x minus x over 2 minus 2x ln of x quantity squared, which then becomes minus x times ln of x quantity squared minus x ln of x minus x over 2 becomes our current y sub p. Now it's important here that we need to notice that this minus x over 2 is really already accounted for here in our c1x, okay? And the minus x ln of x is also accounted for here. So we won't need to use either of these, so that our y sub p will simply become minus x times ln of x quantity squared. And that's what we're going to use to go ahead and put together our general solution for this problem, which is y equals c1x plus c2x cubed plus c3x ln of x minus x ln of x quantity squared. And so this is our general solution that we're going to use along with the information we have here to find out what C1, C2, and C3 are. All right. So I'm just going to write that out again real quick. All right, so now what we're going to do is we're going to take the first derivative and the second derivative of this equation. So the first derivative is going to be C1 plus 3C2x squared plus C3 ln of x plus C3 minus ln x quantity squared minus 2 ln x. And then our second derivative, y double prime, is going to be 6c2x plus c3 over x minus 2 ln x over x minus 2 over x, which can be written as 6c2x minus c3, plus c3 minus 2 ln x minus 2 over x. So now we're going to plug in what we know for each equation to start solving for our constants. So we're going to have 4 equals c1 plus c2, because we'll put a 1 in here and a 1 in here. When you put a 1 in here, this goes to 0 and this goes to 0. So we can say that C1 is equal to 4 minus C2. And then we're also going to have 4 is equal to C1 plus 3C2 plus C3. Then we can say that 3C2 is equal to 4 minus C1 minus C3. And then we'll do the third derivative. So we'll have 2 is equal to 6c2 plus c3 minus 2. And from here, we can go through and start solving. And we're going to solve for c3 first. And we're going to have 2 equals 6 times c2. Oh, I should have finished solving for c2. Sorry about that. Over here, we're going to have that 3c2 equals 4 minus 4 plus c2 minus c3, which will equal c2 minus c3. And so then we will have 2c2 equals minus c3, so that c2 equals minus c3 over 2. And so now over here we can finish inputting this. So we'll have minus c3 over 2 plus c3 minus 2. So we'll get 4 equals minus 3c3 plus c3. So that 4 equals minus 2c3. And so c3 equals minus 2. Now we'll take that and plug it into our C2 equation, so that this then will equal a minus 2 over 2. And so C2 is equal to 1. And from there, we can come over here and solve for C1, because it's going to equal 4 minus 1. So C1 equals 3. Go ahead and add this to what we've been doing over here. So C1 equals 3, C2 equals 1, and C3 equals minus 2. And then we're going to go ahead and plug those into the general solution that we came up with. And so our model for the IVP is going to end up being y equals 3x plus x cubed minus 2x ln of x minus x times ln of x quantity squared. And that is an example of variation on parameters.